Of our next unit, all about circles. And before we can talk about circles, we need to have some common language that we can use to talk about them. So first up, what is exactly a circle? And we've talked about this before when we started talking about equations of circles way back in our coordinate geometry unit. And we will revisit those coordinates for circles. But for now, a circle is just the set of all the points in a plane that are the same distance, or we're going to say equidistant, like equal distance. So equidistant, all those points here, the same distance from that center point, from a given point, the center point of the circle. So that circle, there we're not going to add anything to this image really, but I am going to add a label to this. So I'm going to call this C. And we name circles based on the name of the coordinate at their center. So this one would be called circle C. Okay, so we just draw a miniature circle, and then we have a point in the center, and we use the letter that is at its center. We name points using capital letters. That's also how we name circles, but we use an extra symbol in front. The radius of a circle is that distance that we were talking about, the distance from a point on the circle to the point in the circle, to the center of the circle. So the distance from the point on a circle to the center of the circle. So the radius not only is a distance, but it's also what we call the segment that represents that distance. So this is R. R is the radius. Now, if we wanted to name that segment, if this is point C again, then this would be maybe a point A on the circle, and we just name that using it's a segment, so we'd call it segment CA as the radius. So there's no really new vocab for that. We can just name it like we name all segments. Diameter is a chord. Well, hold the phone. What's a chord? Let's see if we have chord somewhere else on here. We do. So let's actually define a chord before we go back and define a diameter. So chord is a segment whose endpoints lie on the circle. So chord has endpoints that lie on the circle. So maybe A, B. So this would be chord AB. It's just a segment, so we would name it using our typical segment notation. Okay, so in this case, segment AB is a chord. Just like back here on the radius, segment CA is a radius. So a radius has one of its endpoints on the circle, the other one is at the center. Now back to the diameter. Diameter, a chord that passes through the center of the circle. So it has one endpoint on the circle, passes through the center, and has its other endpoint also on the circle. So if this was A, and this was B, that diameter passes through center C, but we'd still name it. It's just the segment AB. It begins at A, ends at B, or vice versa. So it's a chord, has its endpoints on the circle, but it passes through the center. Notice that the diameter is 2 radii put together. 2 radii put end to end. So 2 times the radius is the length of the diameter. The circumference of a circle is the distance all the way around, what we would call on a polygon the perimeter. So we can connect that closely. It's perimeter. When we say circumference, we have that perimeter there. You may have heard this prefix used in other contexts, like someone who goes all the way around the globe has circumnavigated the globe. So that prefix is used in going around the outside. So what the circumference is in our definition, the distance around the outside of the circle. Or that's kind of redundant actually. Distance around the circle would be sufficient. We could just leave out the outside of. We can just say distance around the circle. So the We just measure the entire distance there. It's not a segment this time. That would be that distance. It's a curved. It's not. We can't call it a segment if it's curved. It is an arc that goes all the way around, and we'll define arc a little bit later here. Area is the stuff on the inside, the space occupied by the circle in a two-dimensional plane. The space occupied by the circle in a two-dimensional plane. So all this space on the inside, and we measure area in square units. So even though it wouldn't, like, we couldn't fit squares up to the edge here, we can have parts of squares. So we can imagine a grid being in that circle. Fills up a certain amount of area, a certain amount of space in the two-dimensional plane. So area. There's a formula for both of those values. Circumference, we're going to say is pi times the diameter. So radius, we use r. Diameter, we use d. Circumference, we're going to use c. Area, we use a. Now the circumference, since the diameter is 2 of those radii, diameter is 2 radii. Area, and we'll spend more time on area and perimeter in a future section, but just to get those formulas out on the page here. Area of a circle is, before I get to area. Circumference, pi times the diameter. Since the diameter is 2 r's, we could also say this is 2 times pi times the radius. So 2 times pi times the radius. So both of those formulas are formulas for the circumference. For area, area is pi times the radius squared. Pi times the square of the radius. Radius times pi. And we'll talk about the derivation of these formulas later on. For now, we're just going to get them out there so we can refer to them if we need them. Now, here's some maybe new vocab. So all that stuff that we've talked about so far, you've probably seen in other classes, even if you don't remember it. You've probably seen it before. This is looking a little blurry. I'm going to see if I can fix that. There we go. Okay, so an arc of a circle. It is, just like we talked about with the circumference, it's a curve. So the curve between 2 points on the edge of a circle. So if I have a point here, A, and a point here, B, the arc that connects those points on the circle, that curved edge, is called an arc. Okay, that's an arc of a circle, and we name the arc AB using its endpoints just like a segment. Also like a segment, we're going to put a symbol over the top, but it's not a straight line or a straight segment, it's a little arc, arc AB. That's how we'll name that. That would be a minor arc, an example of a minor arc, which we'll talk about down here. An arc of a circle whose length is less than half of the circle. So we can actually just use that same angle here. So AB is a minor arc. It's less than half of the circle. AB. We just need the endpoints to name it. A major arc, though, is an arc of a circle whose length is more than half. More than half of the circle. So if I have A here, and I could, let's say I still have B here, but I want to talk about the other part of this bigger part. Well, I'm going to need another point to tell me that I'm not just going straight from A to B. I'm going to put another point over here, C. So to talk about this part of the arc, to go from A through C and all the way around to B, I want to talk about that major arc. It's bigger than half of the circle. I'm going to name it also using the arc symbol, but I'm going to name it using 3 letters, A, C, B, telling me I start at A, I go through C, and I end at B, and I'm going to connect those using that arc symbol. Okay, so arc ACB is talking about the major arc, the arc that takes up more than half here. Now, we have a more than half, we have a less than half. We actually also have one that goes exactly half, called a semicircle. It looks like that is not one of our vocab words here. So maybe I'll add that. Maybe we'll add that in class. Major arc, minor arc. If it's exactly half, we call that a semicircle. Semicircle. Some more vocab. the central angle. Okay, so now we're talking about some angles here. The central angle is an angle whose vertex is at the center of the circle and whose sides contain radii of the circle. So, in other words, if we draw a radius on our circle, we draw another radius on our circle. So let's say this is A, this is C, and this is B. We can talk about the radius, or sorry, the central angle is this angle here. And we can name it just like we name any angle, angle A, C, B. But the important thing about this central angle is that the vertex, C, is at the center of the circle, okay? And then the radii are the sides of that angle. Another kind of angle we'll see in a circle is an inscribed angle, an angle whose vertex is not at the center, but is on the circle, so on the edge of the circle, and whose sides contain chords. So if we have a point A here on the circle, and we have a chord that doesn't pass through the center, well, it doesn't necessarily pass through the center, it could pass through the center, B, and then another chord over here, C. The angle A is an inscribed angle because its vertex is on the circle, and the sides contain chords of the circle. So this would be angle BAC, or simply angle A. Okay. We already talked about a chord. Chord is just any segment whose endpoints are on the circle, including diameters. A diameter is a kind of chord. A secant is like a chord, but it's a line, or a segment, or a ray that contains a chord, so it doesn't stop at the endpoints. It passes through the circle. So it has a chord as part of it, but it could be a line or a ray or a segment that extends beyond the circle. That would be a secant. So if this is A and this is B, then this would be line AB. Line AB is a secant. Okay, passes through the circle, contains a chord. Chord is part of that secant line. And then finally, a tangent line. A tangent is a line that intersects a circle at a single point. Okay, at a single point. The tangent line will be perpendicular to the radius of the circle. So visually, we have a tangent line would be it doesn't intersect in more than one. It just comes by, it grazes that point, touches that one point, and goes on. So it's like the circle is resting against that line. It only touches the circle at one point. It might look like it overlaps a little bit. In fact, I'm going to draw this maybe a little bit better. Just touches that at a single point and continues on its merry way. Okay, so it just touches at that one point. That point is called the point of tangency. Point of tangency. Maybe I'll rewrite that so it's not going over the line. Tangency. The point of tangency, point A there. We would name a tangent line just like we name any other line, using 2 points that are on it. So if it has another point on here, or if it has a little lowercase letter in the corner. But let's say that there's a B on here. We could call this line AB for that tangent line. Intersects the circle at a single point. And the tangent line will be perpendicular to the radius of the circle. So if we were to draw a radius from the center to that point A, it would be perpendicular. That radius is perpendicular to that tangent line. Okay? Well, secants and chords are not going to be necessarily perpendicular to to a radius, right? If I draw a radius over here, yeah, definitely not going to be perpendicular. Now, could I draw a radius perpendicular to that chord? Yes, I could, but it's not going to. Not every radius is perpendicular to a chord, but every radius is perpendicular to a tangent line. where it connects to the radius anyway, at the point of tangency. So let's identify some segments here based on that vocab. So BE has its endpoints on the circle, like a chord does, but it passes through the center as well. So this is a diameter. Remember the diameter? It's a chord that passes through the center of the circle. Okay? It's the distance all the way across. DF intersects the circle at just one point. That's a tangent line. Tangent. BC has its endpoints on the circle, doesn't pass through the center, so this one is just a chord. So the diameter, while it is a chord, we're going to use the most specific name for it. So we wouldn't call a diameter a chord, we're going to call it a diameter, even though it's a type of chord, kind of like a square is a type of rectangle. And then AD starts at the center, goes to a point on the circle. That would be a radius. Now, arc DCB, D starting at D, going through C and ending at B, is going to be a major arc. It's a major arc because it takes up more than half of the circle. D, C, B. It goes more than halfway around. Is EC a major or minor arc? EC, just from E to C along the circle there, that is a minor arc. Okay, takes up less than half of the circle. Maybe here would be a good point to call out what a semicircle is. Arc ECB, it ends at has the endpoints on the endpoints of the diameter, is a semicircle. So we didn't have that as part of our vocab, but that's something that we'll need to know going forward anyway. Okay, but we'll talk about that more in class, I think. So we'll stop that there. I wanted to get some of that vocab out of the way. This would be maybe a little bit dry to do all together in class, so we'll get it done in the notes instead. So come ready with your questions in class, and we'll do some more practice then. Talk to you later.